Okay, hello everyone. I'm now start to present the Solar Association Portal Energy High Energy Proton events, which is part of the work package 4.2, which is submitted already in the last December. And basically, Solar Association refers to identifying and linking solar non-alike flares, CMEs, and radiobursts. The occurrence of the energetic particle events, which is in our case observables through solar. So we analyzed energetic electromagnetic radiation, soft X-ray, hard X-ray, gamma rays, as well as radio waves for type 2 and type 3 bursts, and CMEs, which are like imaginary, and put all the stuff in the catalog you already have. So why study this very high energy ACB event? Manon already talked about it, and they just said that from the space weather perspective and the scientific point of view, they are very important to study the particles population through all the instruments we have, and then the structure-driven and also. So the SCP events, two of them, the gradual and the impulsive, and the Manon talked comprehensively about it the last presentation, so I didn't repeat it. So the already goes to identification of soft X-ray flares, which is important because they are associated with one of the two main accelerators of the ceiling is SPs. And the main source to identification of X-ray flares, which is those. And for the first step, we just manually identification of 169, which is now upgraded to 172, I think. Just look at the time series of the goals and pick the very strong flare that related to our SVP. And then we use the developed tool in IRAP. It's about the propagation stuff tools, and then we just pick the onset time of the SCP, which prepared for the work package 5 from the Turku University group, and we just use it as a onset time here, and then put the propagation tool as a SCP on the SCP propagation. And then the tool automatically fetch the solar wind, the speed, and other stuff. And when we pick the protons and the energy range here, we have a broad places that we can select our powerful solar X-ray flares in the area. So. And then we had a hard X-ray flares that we use RESI and sticks for them. The RESI between the 2002 and 2018, and the energy range is 3 keV to 12 mega electron volt, and it's a part of the catalog used the RESI one, and the sticks started on the solar orbiter started from 2020, and the range of 4 to 150 keV. And we just select we consider the hard X-ray onset time with the soft X-ray flare onset time we already choose for the SCP, and we have an additional criteria, which is if hard X-ray starts before the soft X-ray onset time, we said that not associated, and if they delayed more than 30 minutes before after the soft X-ray, it's also not associated. We have challenges with the RESI and sticks because they are limited temporal and spatial coverage. They only observe the Earth faces solar disk, and the occulted flares, which is the behind the limb, they are just have very weak or not recorded hard X-ray. So the result from the first result from the 169 SAP events, we have 74% of the events included with the flare longitude, and we have 34 fireside events that we should study in deep after this deliverable, I think. The distribution of flare locations support the importance of the good magnetic connectivity to the Earth because they are mostly on the western side, and also cover the idea that the strong SEP events are typically associated with the M-class or the stronger flares. So the next, so that the time differences between the onset time of the SEP and the peak time of the solar X-ray flares, and most SEPs are released during the impulsive phase, which is very close to the SRE peak intensity, and it's support the idea that flare-associated acceleration process mainly play a major role in producing the very energetic SEP events. And we updated the catalog as the submitted. After the submitted one, we add this start time, peak time, and peak intensity, energy range, and location, and the observer all the hard X-ray flares. And also we updated the flare location based on the X-ray flares that we marked as uncertain because of the complicated events and so on. So we have other results that show that it also the location of the solar flares, which is on the western side of the solar disk, which is also the good connectivity to the Earth and propagation effect, the solar Tesla interactions. And also we have the flare location based on the intensity of the flare, which is most intense one on the western part. So the identification of the type 3 and type 2 bursts, we use the ground-based and spaceborne radio observation, mostly wind and stereo. And we try to cover all the frequency range from very low frequency to the high frequency range. And we add the E-class station as a ground-based newly, and we compared for the events with the all newly catalog release, for example, with Mohan in 2024. And yeah, we updated the catalog based on that. So the majority of the SEP events are also associated with type 3 bursts, and the time difference between the onset time of SEP event and type 3 start time of the type 3 is really close to each other, which is supported that the idea that they're I mean, the release proton, the release particles as the electron beam is very close to the propagation of the also particle acceleration. So, and also the time onset time of the SEP and type 2, which is 95% of the all SEP events. So identification of the CME, we mostly use the Soho-Lasco catalog, which, and I think we fill all the part of the speed, the white, and then other stuff related to the SEP from the Lasco. And the new release version of the catalog, it's coverage the 1996 to 2025 January, which is basically cover all our data sets. This is the first result of the CME, which is said that the CME speed, mostly there are high speed CME, which is the mean of the 1,404 kilometer per second, and the time difference between the onset time of the SEP and the CME is very close to each other, which is normal. So the very high SCP event, the very high energetic SCP event, mostly related to the very wide CME, mostly hollow CME, which is also confirmed before through the Atanas paper in 2016, which is corrected as confirmed here as well. And I also plotted the CME space via flare intensity, which shows that the very intense flares have the very high speed, which is normal. And it's also the right-hand side plot also said that the black events is related to the catalog Salazar Matanos in 2015, and the blue one is related to the Manon's study on her thesis, and the orange one is related to ours data. So they're very much correlated with each other. So the identification of gamma ray is basically this newly analyzed, and we use the Fermi-Lat instrument, which is covered 13 mega electron volt to 300 giga electron volt, and basically 40%, only 40% of our SCP events have this association with gamma ray events, which I try to very preliminary study about the lat event duration and type 2 frequency, which shows that the sustained gamma ray event and the end type 2 frequency, at least 4 or 6 of the events is closely related to each other. And yeah, we are mostly updated our catalog based on the updated the location of the X-ray flares, and then mostly hard X-ray flares, and then we updated our radio burst data based on the ground-based observation and at the eCalasto data. And then we mostly at the start time and end time of the Fermi-Lat data and the flux over 100 mega electron volt. And so far, that's it. Thank you.
Okay. Questions, Bernd? Thanks.
Yeah, thank you very much for the very nice overview. The hard X-ray you plotted, is that a Fermi, the Fermi BGO, or what are you using for the hard X-ray counter?
Oh, just the sticks and the RESI data.
Which one?
Sticks and RESI data.
Okay, yeah.
Yeah.
So which energies you are using it? 100 keV, 300 keV, or what are you using there?
Yeah, I think 100 keV. Yeah.
Okay, in a very hot flare, you can still have thermal components in that, right?
Yeah.
Okay. So,
but we
by the way,
are going to the deep analysis of all of them in the future, I think.
And Fermi BGO, is that in your plan?
GBM?
Yeah.
Oh.
GBM as well.
Yeah.
So we haven't done GBM, but typically that's something we could use as well. Yeah. And we have a meeting at IRAP in June to also exploit, I forgot the name, there's a new detector on a Chinese mission that's measuring similar energy ranges as GBM. So we're meeting the astrophysics team to discuss that for future events.
Yes.
By the way, the very stupid question. Now things are going to do with AI. So if you want to look, I mean, you showed this very nice plot of the corresponding solar map, and then where you have the flare and so on. Is there any chance to do that by AI, so that you have? I mean, this is a tough work doing it by eye. So
yes.
Is there any ideas about this?
Well, it can be do, but it's doable, but it's a bit hard for me to, because I'm not expert in the AI. So.
No one is, everybody's playing around. So I see Alexander Warmuth has a comment.
Thank you. So do you hear me? Can you hear me? Yeah,
Yes.
great. Yeah. Hi, everybody. I'm sorry I can't be with you in the room. Just a follow-up to Bernd's question. So at 100 kV, we are never contaminated by thermal emission. So that's really safe. So everything above 50 kV, I would say, is purely non-thermal in the X-ray spectrum. So that should be fine. One question on the flare locations. When you're using sticks, where do you get the flare locations from? Do you use this list that was compiled by Laura Hayes?
Yeah, I found it on the GitLab, GitHub, yeah, and I import from there, basically.
Yeah, that's the way to go.
Yes, yes.
On the event selection, so you were using the onset times, right? Both for soft X-rays and hard X-rays. Of course, especially in hard X-rays, I think the onset times are often not that well defined. What's always much easier to identify than an onset is of course a peak. So I would just an idea whether you could also exploit the peak times as at least as a check.
Okay, thanks. Yeah, sure.
Thank you very much. So a comment also from Piers.
Maybe I missed, did you show a plot of the X-ray flux against the greater than 100 MeV proton peak intensity?
What?
Did you plot the X-ray flux, again, or the peak X-ray flux, let's say, against the peak greater than 100 MeV proton intensity?
No, that's Manon presentation.
Then I missed. Okay, I missed it. Sorry, Manon. I'll look back on your presentation.
I can open it if you want.
I wanted to see if it looked the same as the one we had before, where it was quite strong.
I opened.
Especially with 300, it was very strong. I remember 100, I guess, it was a bit less strong, but I just wanted to. Okay, but this now is a count rate on the y-axis, right? This intensity, is that a greater than 100? Like, have you defined the count rate such that you're sure that these energies are the high?
Those are intensities, so the unit is wrong, I would guess.
Okay, fine. So
from the numbers.
Well done, Rami. Okay, so it looks okay, but not as clear as the greater than 300. Okay, thanks. Yeah.
Yes.
Just a comment on CME speeds. You look at different catalogs, they're different. You get different speeds, and there are big errors on. There are probably 10% errors on those CME speeds. You look in the catalog, you see it, there's 4 significant figures and so on, but there are errors in those CME speeds are uncertain. They're measured in different ways by different people. Just be aware of that. We tend to forget that in the SFP community.
Yeah. Okay.
But they aren't set in stone like that. They're a bit uncertain.
Sure.
Okay, any other questions here or online? So I guess not. So thank you very much, Nasrin. Sorry, I can't do this with that.